When it comes to multiplication and division facts, you're going to want to start with subitizing as a basic skill. And within your subitizing cards, you have two different sets. You have these that have area models and partitioning on them. And then you have these that have different representations of equal groups. We're going to set the area model partitioning cards to the side right now, and we are just going to talk about some activities with these equal group cards. Now, the three activities I'm going to show you are very similar with just little differences, so I'm going to put them all in the same video. You're going to shuffle the deck, and the first game we're going to play is what do you see? I'm just going to ask students to tell me, what do you see? I see 3 groups of 7. I see 3 groups of 5. Let me get to a different one here. I see 1 group of 9. I see 2 groups of 9. See the point? That's all they're going to do. The goal of this is to be able to visually recognize the number in each group. As I mentioned in the notes, if students struggle with that, you need to go back to the first type of subitizing in addition and subtraction, and you can find a video about that as well. The next activity is to get kids to skip count. So, same thing, I'm going to ask you, what do you see? But this time, you're going to skip count to tell me how many in all. So, I see 2 groups of 9, 9, 18. I see 3 groups of 5, 5, 10, 15. I see 3 groups of 7, 7, 14, 21. Now, you may need to use a 100 chart to have students be able to skip count, and that is definitely a possibility, but the goal of this is to skip count so that they're moving past the visual recognition to now being able to count to find how many in all. The last one is to just tell how many in all. So now we're going to say, how many in all? That is 2 groups of 7, 14. How many in all? 3 groups of 2, which is 6. How many in all? 3 groups of 4, 12. You see the point here. So the goal is for students to work across those levels to be able to visually recognize those basic facts. Now that we've talked about how to use the visual subitizing cards, we're now going to talk about the area model subitizing cards and how that's going to help students partition harder facts. So we are going to play 3 games the same way as we did with the other cards, but they each have just a little bit of a different look to them. So the first one is similar, I'm going to move these out of the way, to what we did before when we just said, what do you see? But this time I want students to see the shaded and the non-shaded part. And you can turn the cards however you want. It's totally up to the student, but you will shuffle them and ask them the same questions. What do you see? I see 5 groups of 4 and 3 groups of 4. I see 5 groups of 4 and 2 groups of 4. I see, get the point here, right? That's all they're doing. Just identifying them. Now these are groups of 4, but it goes all the way up so that you can see which facts you're using. You'll notice that the non-shaded portion is a group of 5. So what we hope students recognize is that they're going to start looking for that group of 5 and then see that the shaded is more than 5 each time. Now the next part that we're going to do is start to write the fact that goes with those sets. So we're going to use the associative property to group this and partition it, and you're going to want students to write on a whiteboard. I'm going to write on this board right here so that you can see it. So I'm going to do the same thing, shuffle the cards, I'm going to show it to the student. I'm going to say, what do you see? I see 1 group of 4 and 5 groups of 4. So we're going to record that as 1 group of 4 plus 5 groups of 4. And you're going to ask students to record this and then solve it. So this is 4 plus 20, this is 24. So they will do that for each card. They'll go through it. So let's go back to this one. This is 3 groups of 4. This is 5 groups of 4. So when I write them down, work through it, what am I going to get? We're trying to tie this abstract notation, the ability to think mentally and partition the fact, to the visual. Now the third variation is just like what we did when we were doing the equal groups card. We're going to ask them to do this, but to do it all mentally, so without writing it down. So when they see this card, they're going to say, this is 5 groups of 4 and 3 groups of 4. This is 20, and this is 12. 20 and 12 is 32. Now, if that's too hard, you can also add in just encouraging them to write on the card, so we're getting a little bit closer there, to go ahead and write the products of those without the equation, the products of those, so that they can see the total product. So again, we can do it this way. I've got 2 groups of 4 and 5 groups of 4. This is 8, this is 20, so the total product is 28. Again, you can write on there if you want to. It's the nice thing about them being laminated, but the goal is for them to start moving to that mental computation, and that's why we move up through the steps. Using number bond flashcards is a great way to get students to visualize operations, and these are great because they can show multiplication and division. Now we are going to sort the cards by the ones that have 2 factors and a missing product versus the ones that have the product, or you could even say the quotient, and one of the factors, or the divisor, depending on how you look at it. So these we're going to set to the side, because right now I just want to focus on the basic level. We're going to focus on the cards that have 2 factors, and we are trying to find the product. Now in this activity, I want students to think about equal groups. And so all they're going to do with this, and you can choose to do this with manipulatives or just having students draw a pictorial model. I dropped my marker. Ugh, here it is. Okay. So in this one, got my card. I'm going to ask students to tell me about this card. So I want them to say that this is 4 groups of 5 or 5 groups of 4. Now they might choose, if they're counting, to show this with counters, and then I'm going to ask them to count to find the product. Or if they're moving on to the skip counting, they might be able to say that this is 4 groups of 5 and be able to skip count 5, 10, 15, 20, which would be great. Or if you don't want to use the manipulatives, but you still want them to show the quantity, they could go through and show equal groups of 5, count those to find the product. So we're either working with the concrete or the pictorial here to show the product of what's represented on the card. This activity is going to require us to use the number bond flashcards in the same way as we did the last one, sorted with cards that have 2 factors and are missing the products. We'll come to the other cards in the next activity. The goal of this one is to skip count. So I have a 100 chart in a page protector, or you can laminate it, and I have a dry erase marker so that we can draw on it. What we are going to ask students to do is, again, to describe the card and using the groups language, that this is 4 groups of 4, and then show it by skip counting on this 100 chart. Now obviously it would be great if they could skip count mentally, but this is just a scaffold to help them there. So 4 groups of 4, or 4 fours, we are going to put a box around every number that is that group of 4. So 1, 2, 3, 4. So I'm going to put a box around 4. 1, 2, 3, 4. A box around 8. 1, 2, 3, 4. By the way, whenever students go to the next row, that seems to be a challenge for them, thinking about how it's going to carry over. 1, 2, 3, 4. So I see that I have 4 fours by the 4 boxes that are represented here, and then I ended up at 16. Let's try another one where the factors are not the same. So in this one, I have 10 and 3, which could be 3 10s, or it could be 10 3s. You want to encourage students to think about which one makes most sense for them, or which one might be the most efficient. I like to make them do both. So one thing we could do is have them do 3 10s, which, ooh, look at that. It is all along the side of the hundreds chart. Look how nice that is, right? And I see the answer is 30. And then we can ask them now to do 10 3s and see the difference. So here I go with my 3. There's 1. Oh my goodness, there's another one. Oh, this gets tricky when I have to go to the next line. And so on, and they keep going. The goal is for them to see patterns when skip counting and to get more efficient using this hundreds chart to count. To help students bridge the idea of concrete to a more abstract model, we're going to use an array model with dots to help them work that counting to the partitioning idea. So we're going to use number cards. These are from my addition subtraction bundle if you want to grab those. Or you can use just numbers 1 through 10 or a dice, however you choose to use it. Just shuffle them and you're going to ask students to show what is on the card. So I've got 6 and 7. This can be 6 groups of 7, 7 groups of 6. And then you're going to ask students to draw a rectangle to represent this. So we've got 3, 6, 1, 2, 3, 4, 5, 6, 7. Counting and talking at the same time can be a little challenging sometimes. So we've got that here. Now I'm going to ask students to partition this rectangle into a way that's going to help me to find how many total dots or the product without counting each one. So I know that I could partition this into 2 groups of 6 because I know that fact. I know that 2 times 6 is 12. And I actually have the students write that in here because I think it's really important for them to see that math fact. And now I see that when I partitioned it to show 2 times 6, that I'm left with 5 times 6. And I can count by 5, so that's pretty easy, and I get 30. Now there is some space down at the bottom if the students want to write 30 plus 12 and find that that's 42, or they could do it mentally. Totally doesn't matter. But the goal is for them to partition the rectangle, show the components, and then add them. And we would just erase and do it again with more of our numbers. Sorting number bond flashcards are a great way to get students to look for the relationship between part whole and to start identifying fact families. So whether you choose to lay it all out as like a memory game or just a sorting activity, provide the students with the cards and ask them to find the ones that have numbers that are in common. So for example, this card here has the 2 parts 4 and 7. This card here has the whole 28 and a part 7, and this one is a part 4 and a whole 28. These cards all represent the same fact family, and I can show them with multiplication and division equations. Same thing for this relationship of 4 times 10 equals 40. So as I said, sort them, put them as a memory game, but encourage students to look for the way these number bond cards share the same numbers and the same fact family. Another great way to sort these number bond flashcards, but probably more challenging, is to think about how facts can help you solve other facts. Now, I would sort my cards with the ones that have 2 factors and a missing product because our goal is to think about multiplication here. So what I'm going to ask students to do is to locate a card that may help them to solve this fact. So here I have 4 times 8. What would be a fact that I might be able to use to solve this one? I could use 4 times 4 because I know that 4 is half of 8. So if I find 4 times 4 and double it, I'm going to get this answer. Now that's not the only answer. They may choose to use 5 times 4 because I know that if I have 3 more groups, I'm going to get 8 times 4. The cool thing about this activity is students can defend their answers, and there's not one answer. There's more than one answer. So this is a great activity to get students to stretch their thinking and defend their answers. Because you could even extend it further and say, well, how would this fact be used to find 4 times 10? Can this fact be used in more than one way? Yeah. So great conversation piece, higher level thinking, and a great way to get students thinking about their math facts.